So this is going to be a talk about the Calanais stones, but not the stones in particular, more about the landscape that's around them. And as was mentioned, this is a project that came out of the funding from Historic Environment Scotland, the Year of Waters and Coasts. And there's a large team that's been involved in that, and many more local volunteers that are not actually on the list of names up here, too many to mention. I'll give a little introduction to the project first off, and then try and talk about some of the results. It is still ongoing in terms of what we are doing both at the site and in post-site analysis of particularly the sedimentary and environmental results that we've got back there. And at the end, I'll try and summarize with some future directions, or probably more just future questions of what we want to do and where we want to go with it. The landscape project is aimed at initially at developing and investigating tools for exploring the landscape and for reconstructing the paleo-landscapes that are there. The site itself needs no introduction, really. It's iconic. It's well known not just in Scotland, but of course internationally as one of our most important and recognised Neolithic stone features. But that said, the environment in which it stands, there is relatively little known. And that's, of course, because of the problem that we have throughout much of Scotland to do with peat and peat growth subsequent to the Neolithic. This, part of the Scottish landscape that really makes Scotland a recognisable place that it is today, but is the bane for a lot of our archaeology because it's hiding a lot of the archaeology that we really want to get at. And many people have attempted to look through the peat, and this is another set of attempts to do that. So we're trying to do that to understand and reconstruct the paleo landscapes, and of course to be able to target better future invasive investigations. So we can't dig everywhere up. We don't want to dig everywhere up. We don't have the finances to dig everywhere up. So where do we look within the landscapes if we want to be best? We want to get this whole picture, but we want to do that by targeted investigation. And of course, the Calanais site has been the focus of investigations over many years here. Patrick Ashmore's work, particularly given us the understanding that we have today there, written up in the survey and excavation reports from the 70s and the 80s. And there are many projects that are going on there today. And in fact, later today, you're going to hear about one of them that's looking at a different aspect of the landscape, and one that we are starting to understand is particularly important within these Western Isles. So with Fraser and colleagues at Reading University, and we're going to hear, I think, from Stephanie later today about some of that. So our objectives really were to present the standing stones within their broader archaeological contexts. And because this was a community-funded or community-driven program, we definitely wanted to, at the beginning, involve the local community. It's not just about the academics, but it's about the people who are living in and around the site and getting those people involved in the work. And of course, to use the results to better promote the site as well, in particular for the Calanais Centre that is located at the standing stones. Ensuring the landscape and its heritage make a significant contribution to the economy. Of course, these are the things that HES is trying to promote. Very much. From our point of view, if you want the academic, we're trying to, as I say, understand the individual standing stones within this wider context. And not just the stones at the main Calanais site that most people visit, but if you've gone to the landscape then, I'm sure most of you have, it's the other stone circles within that landscape that we feel are equally important. And to understand the ones on the main site, we need to understand all of those other locations as well, to the relationships between them. And today, we've already heard about relationships within landscapes, different archaeological features, and the fact that if we're going to understand our sites, we need to put them into these broader landscapes to be able to get that full understanding. So those are the kind of the objectives of it. As I say, I'm not going to dwell on where it is. Maybe there's a few people, if you are listening internationally, you don't know where Calanais is, but there it is in the Outer Hebrides on the Isle of Lewis, on the far northwest coast, looking out to the Atlantic. That's the valley that it's set in, the red pointer there representing the main site itself. And then numbered around that are the other stones consisting of individual stones standing in this environment to other stone circles that are more complete, so 3, 4, 5 or more stones. And these would all be classed as the great stone circles in there. There's been various classifications of the sites, but the most important ones are marked in here. Now, we didn't get to all of them during our project, but I'm going to talk about a few of them here. I'm going to talk about site 10, site 11, site 2 and 3, and give some results from the investigations at those individual sites, show you what we found at them, the techniques and technologies that have worked, to enable us to try and start to get an impression of what the landscapes were around there, and to start to reconstruct what we think it might have looked like back when these were being built. I said peat was a problem, and I put this slide in here because, of course, the main site we know in its sort of completeness that we see it today, because the peat's been taken away. And there's some classic etchings from the 1800s of the immediate post-peat excavated sites there. You can see what looks like a tide mark on the Sir Henry James image, if you want the etching there. This tide mark being the result of the peat being removed from the site. So when they came there originally, there was maybe half, 2/3 of the stones poking out of the peat. So they knew the site was there, but certainly not all of what we see today. And of course, this is a big problem, this fact that this peat has grown up and the prolific peat growth subsequent to the site being constructed. So peat growth really kicking in 3,500 years ago in this part of the world, covering the sites, and particularly covering them if those stones are no longer standing upright. And I'll talk a little bit more of that when we look at site 10. A little bit about the stones. As a geologist, my background, original degree was in geology. They're Lewisian gneiss. As a geophysicist, that's important to know what the stones are made of if we're going to go and try and look for them within landscapes. If we're looking for understanding things that are buried, we need to know the signatures of what those materials are. Lewisian gneiss, it's a very electrically resistive material, and so I'm already thinking that if we're burying that in peats, and peats are waterlogged, often the peats are more electrically conductive. This is where I'm starting to think now about how we use remote sensing to investigate these sorts of landscapes and look for things within them. Of course, the bedrock here, as I say, Lewisian gneiss, the sediments that these things are buried in, or on the surface that they're buried on, is till resulting from previous glacial retreats in this part of the world, and then the peat growing up on that surface. So we've got, in general, a sort of a cross-section through the sedimentology here that starts with the bedrock, this Lewisian gneiss, on top of which there are soils or degraded soils resulting from the till deposition on ice retreats, on top of which the peat has grown and the agriculture has been enacted subsequent to that today. So you've got that kind of a sequence which we need to see through if we're going to try and reconstruct things. So a number of different approaches to reconstructing it. Scape, University of St Andrews, Tom Dawson's group came to the sites, around the sites here, and did some coastal walking. They were updating the recording of what was being found along the coastline, eroding out of the coastline, and like most places around Scotland, there's a lot of erosion going on the coastlines, and artifacts, features are coming out of the landscape. So with the community, they walked a lot of the coastlines around here just to update the records that we have in Canmore, etc. In fact, while they were doing that, 34 what they called new sites were added to the databases. And these sites, of course, are everything from prehistoric to post-medieval, things like stone alignments, enclosures, embankments, walls, cairns, were found in their field walking. 28 of existing sites on the records were updated during the walking on here. And you can see some examples of what was being found while this group was going around there. The flint finds, you can ask Alison about those later on, as she's taken them to look at more extensively. On the geophysics front, we couldn't obviously record everything everywhere, so we focused on a number of individual sites. And here we're using a range of geophysical techniques, from magnetometry, magnetic susceptibility recording, electrical resistivity, electromagnetics, and we were doing things not just on a land base, we were doing things from the air with drones, and in the drones, not just recording topography, but looking at the multispectral signatures of the features on the ground, just to see what might enable us to not only record the sites in better detail, but try and see through, as I say, the peat at these sites to record the landscapes around them, the landscapes in which the sites would be contextualized. It's not only land, though. Of course, there's a marine or a submerged history that goes along with this area. As all of Scotland, subsequent to last glacial maximum 27,000 years ago, as the ice retreated, we've got a complex history of sea level rise. And that sea level rise is not uniform everywhere. It's not a uniform just that the sea came up to where it is today. It's a complex sea level rise. And that, of course, forms part of the story of the landscape and the landscape change in all of our coastal locations for archaeology that we're looking at today. And the Loch Rög area is no different to anywhere else. So we wanted to get into the marine setting to actually understand that landscape evolution, because a lot of these sites are very close to the coastline today, and in fact extend down into the intertidal, and in fact extend into the subtidal parts of it. So we were not only surveying on land, we're surveying in the water as well. So let's look at some of the sites and the results. I'm going to start at site 11 here, and site 11 sits directly to the north of the main Calanais site. It's about 1.5 miles to the north of it. It's on a slight rise in the landscape. And in fact, from site 11 here, you can look down south directly to not just the main site, but you can actually see most of the other stone circle sites within the Loch Rög area. So we felt that that was a good one to start at. It only has one remaining standing stone on it. And in this kind of rather confusing map that I'm showing you here, the red dot is the one single standing stone that's remaining on the site today. It's been recorded that and speculated by probing the peat that there is stones that are buried beneath the peat that represent the circle that once stood at this site. But there's been no excavation at it, and there's been no previous geophysics work done. So we hit the site with as many different techniques as we could, and here are some of the results. So this is the result of looking at ground conductivity measurements. Again, I'll orientate you always by that red dot on there is actually the remaining single stone that exists on the site. So this is electromagnetic conductivity, and it's high conductivities in the yellowy browns and low conductivities in the pinks and the purples. Now, low conductivity means high resistivity, and high resistivity, I said to you, was associated with the Lewisian gneiss. So in general, you've got Lewisian gneiss close to the surface in the pinks on here, and you've got deep peat in the yellows and the browns. So the actual single standing stone there is in an area where it's deeper peat. But it doesn't show us very much more than that, the fact that we've got kind of a terrace or a bench of this sort of peats around where the supposed stone circle is. That's electrical resistivity. So looking a bit shallower than the previous map I showed you, that previous map was probably looking down about 1 meter. This is looking down about 10 to 20 centimeters. And again, the circle represents a single standing stone. We're not seeing very much in there, some changes in resistivity, but no great patterns that you could associate with if, for instance, buried stones that might be in a circular setting. Here we've got the electromagnetics, and I've showed this in the bottom there as a sort of a draped on the topography, and cut through that an electrical resistivity tomography section. And again, it doesn't show us anything that is in terms of buried features, but it does give us the sense of the depth of the buried peat. And in fact, it's at least 2 to 3 meters on the site based on this electrical resistivity section in there. Again, you can see in red in the cross section, the reds associated with the Lewisian gneiss, and the greens and blues associated with the depth of peat on that site. Magnetic gradient on here shows us perhaps something slightly different. And again, the red circle there marks the single standing stone, and it was associated with a dark spot on here and a light spot. So if you want a bipolar anomaly associated with this standing stone. And you can see across here, I don't know whether this mouse is going to work. No, it's not working very well, but you can see other bipolar anomalies there's around here. In fact, around the site, if I put a green circle on them, there's a whole sequence of these, positive, negative bipolar anomalies. And we would interpret those by comparison with the one single standing stone that is extant on the site there, that these other black-white anomalies could also be associated with stones, but ones which are actually buried in the peat because there's no manifestation of them on the surface here. But of course, this big black-white thing in the middle of the stone circle, and another one off to the east side of it, is really what grabs your eye. A sort of cruciform, it's certainly got a north-south-ish, east-west-ish extension on what we would call a large bipolar anomaly. I had never seen anything like, or recorded anything like this in geophysics in the UK before. I have been part of surveys in much drier parts of the world, in deserts, where you get features like this, and they're associated with lightning strikes. And so here at the center of these bipolar ring of anomalies, there is the manifestation of a large lightning strike within the magnetic gradient signature. That's how it looks if you extend and extrapolate where we think there might be buried stones. That's where the lightning strike sits with respect to this potential stone circle or set of stones which are buried beneath the peat now that could have represented the stone circle. Lightning strikes are interesting. To preserve them within any landscape, it means they must be preserved in a rock that is highly resistive. That's great because the rock here that is highly resistive is Lewisian gneiss, and we know that's the bedrock underneath the signature. This lightning strike would not be preserved in the peats, and that's because peat is, as you all know, a very wet substance. If lightning hits the ground and it's wet, then the signature of that is not preserved. The electrical conductivity of the soils and the peat in this case just disperses that signature. So we know that the lightning strike is in the bedrock, and because it's been preserved, it must have been preserved before the peat started to grow. So at some point in the past. I will leave you to speculate on whether that was there before the stones were laid in a circle, or the stones were laid in the circle after the lightning hit the center of that stone circle. That's another view of it there. Interesting, nonetheless. Going to move on, not dwell on that. This is site 2, Calanais site 2, very much closer to the main site. In fact, it sits just to the east of the main site. And let's look at some of the geophysical results from that. This is multispectral signatures. In fact, this is what we call the red edge. It's a particular frequency of multispectral data taken over the whole of this area. And just to pick out some of the features around the site, site 2 there is marked on the east side. In the shallow intertidal area, you see the multispectra picking out actually very, very nicely stone features within the intertidal zone here associated with probably walling and fish traps in this particular area. Not to dwell on those, let's go on to the actual site itself. This is site 2. I'm sorry, the little green dots on there, which represent the upstanding stones on the site today, are a little bit small to see. I should have made those larger. Apologies for that. But we do see different parts of the electromagnetic spectra showing up with association with those upstanding stones. and occasionally showing up with things which are potentially buried within the soils at this particular site itself and within the peat surrounding the site. There's the results for magnetic gradient on the left and the electrical resistivity on the right. Some of the features are showing up in association with stones, some are not. And what we're finding here is that the geophysics, any individual geophysical technique isn't the sort of cure-all, the magic technique to use at any one site to find out what is in the peat or not in the peat. The multiple techniques have to be used. Ground truth in some of this, well, we had the local community out again helping us off the sites, off the protected sites, digging holes in the peat to try and understand what signatures we were seeing and associate with them with things that were buried in the peat to get ground truth correlations. You can see that the youth of today just sits around on the right-hand side there while they leave the older folks to get on with the real work. Isn't that always the case? Site 3 here, site 3 slightly more interesting. There I've marked in red with the magnetic gradient where the stones associated with the site are seen today. And actually what you can see is that again, they don't all show up with magnetic signatures. And I think in this case, it's because, again, we've got this as Lewisian gneiss. Lewisian gneiss is not a particularly strong magnetic signature associated with it. But you do see an arrangement of magnetic signatures that not start at the same site, but come to the south of it. Again, we have not got permissions to investigate any of those, but they would be targets for the future. Electromagnetic conductivity, again, it's not really showing us anything that's associated with those stones on this site, but might be associated with the depth of peat to the buried bedrock or landscape surface beneath it. Again, in the multispectral signatures, this is again for red edge and what we call the NDVI, which is a combination of different signatures. Again, you're seeing an association with some of the features on the ground, but not all the features. So more work in progress, more work needed to try and understand what's happening here. I'm going to jump up to site 10 here for a minute. And this is, of course, is one that Colin Richards had investigated and removed the peat from the site. And it's an unusual one in the fact that the stones have fallen over, mainly because they were badly packed on very, very thin topsoil when they were initially erected. And here you can see one of the stones standing there on the very, very thin topsoil today on the top left. And these two other images are our attempts to reconstruct what this site would have looked like when that peat was actually there and in growth. And I will see if we can get this to play. No, that wasn't going to play. Okay, sorry about the technology there. There's a small video that I was going to show you about reconstructing these stones, but we're able to take the landscape around here and put it back to what it was at the time the stones were erected. And in fact, because we can scan each of the individual stones, we're able to re-erect those into the positions that they were, and then go further than that to actually model then this arrangement of stones in terms of things like the moon set, the moon rise, sunrise, sunset at different periods in the past. So going further than just thinking about the landscapes in the past, but actually modeling what they were doing in the past. I'm going to finish up by just showing a little bit of the marine results in here. So this is the intertidal. Intertidally, we're from the walking on the shoreline, we're seeing stone walls coming out from underneath the peat. So in other words, the peat growing up on top of them. And we've got what's more extensive than just the peat. There's a lot of wood material right at the base of it in certain places. So I would hesitate to call them forests, but we've certainly got woodlands that are occurring at a time period before the peat grew. As we get into the loch area itself, then we can extend those landscape surfaces. And in fact, there's some of them we've dated back to some of the first inundations of the valley area leading up to the main site itself. You see the main site there on the north end of this map of the Loch Rög itself, and what we would call the Paleo-Loch Rög Valley that we've been trying to reconstruct. First inundation around 8,000, 8 to 9,000 years ago. But interestingly, in the areas just to the south of the main site itself, we've got a very much later inundation in there. So here's some of the offshore records sliced through those buried landscapes. They've been buried by modern sediment today. We've been able to core through them and get this more, start to try and understand the complex history of flooding of this area. We're doing that. We're also modeling the area and trying to model that sea level rise. This is just one model for the site. You can see that going back 8,000 years ago, I said that was the first initial flooding. And in fact, our models would suggest that we've gone above sea level today before it drops down beneath sea level to come back to where it is and what we see as the landscape that we work on today. So complex history potentially in this area of flooding. Now, this data and this model work has got a big health warning with it, because we've got very, very few well-dated places within the landscape in the Outer Hebrides to be able to reconstruct to make these models. But just the fact that we get models that come out with a great complexity means that we should be looking in more detail to what that landscape change and environment change has meant over the last, well, particularly between 8,000 and about 3,000 years ago. That's really important because, of course, that's the time period that all these places were being occupied and the stone circles were being put up and the people were doing what they're doing in their places. And I think Stephanie's going to talk more about that later on. Critical time period in this part of the world that needs a lot more data. So hopefully we're going to use what we've learned on this, the techniques that we've identified for mapping. We're going to extend them out now to do a lot more of the mapping beneath the peat. To be able to understand those stone circles, where they are, what they're about within that landscape more generally. We need more data on the sea level rise, this complex inundation story. So we're still working on the environmental record and getting dates for that. And we'll hope we'll be able in the next year to get a much more definitive history for the area. So that's what we're going to work on. A lot of this information is going to be, we're working in partnership with the visitor centre. So as they extend and hopefully build new parts to that, this information will go into there, along with various research findings, as always, as academics in publications. Greater understanding of the landscape and the people who live within it. That's always our goal, and we're still working on that. Great, thank you very much.